In our last video, we saw how if we have one-to-one functions such as a straight line graph or an exponential graph and we take its inverse, the inverse of one-to-one functions remain a function with the geometrical property that both of their graphs are symmetrical about the line y is equal to x. But what about if we have a function that is not a one-to-one function? Well, in this video, we're going to look at how to find inverse functions of non-one-to-one functions. Let's consider what happens if we take the inverse of a many-to-one function. For example, consider the function y is equal to x squared. To get the equation of the inverse, we simply interchange the variable x and y so that its inverse will have the equation x is equal to y squared. Now, both of these graphs are symmetrical about the line y is equal to x, but x is equal to y squared is not a function because it fails the vertical line test. It is what we call an inverse relation. Let's also look at another example. Consider the function y is equal to sine x, which is also a many-to-one function. To find the inverse, we interchange the variable x and y, so we're going to get x is equal to sine y. Both of these graphs are also symmetrical about the line y is equal to x, but x is equal to sine y is also not a function because it also fails the vertical line test. It is also an inverse relation. So what we can conclude from here is that if we take the inverse of a many-to-one function, what we're going to get is not an inverse function, but an inverse relation. But this doesn't mean that a many-to-one function cannot have an inverse function. If f of x is a many-to-one function, we can restrict the domain of f of x to create an inverse function. We want to restrict the domain of f of x in such a way to make f of x monotonically increasing within that new domain, which means that as x increases, y also increases, or we can restrict the domain of f of x to make it monotonically decreasing, which means as x increases, y decreases. Let's look at some examples on how this can be done. Let's consider the example of f of x is equal to x squared. If x is less than or equal to 0, then our function f of x is monotonically decreasing, and if x is greater than or equal to 0, f of x is monotonically increasing. If we want to have inverse function, we can either restrict the domain to x is less than or equal to 0, in which case we're going to get this left half of the function f of x is equal to x squared. And this is going to give us the inverse function with the equation negative square root of x. However, if we decide to restrict the domain to x is greater than or equal to 0, we're going to be looking at this half of f of x is equal to x squared, and the corresponding inverse function will have the equation of positive square root of x. So we see that by restricting the domain, our many-to-one function can now have inverse functions which are symmetrical about the line y is equal to x to the original function. Let's also look at the relationship between the domain and range of f of x and its inverse function. From a previous example, when we restricted the domain to x is less than or equal to 0, we get this half of the parabola, and this is the corresponding inverse function. The domain of the original function is x is less than or equal to 0, and the range of the original function is y is greater than or equal to 0. For the inverse, the domain is x is greater than or equal to 0, and the range of the inverse is y is less than or equal to 0. What we see here is that the domain of f is the same as the range of the inverse, and the range of f is the same as the domain of the inverse. What about when x is greater than or equal to 0? The domain of the original function is x is greater than or equal to 0, and the range is y is greater than or equal to 0. So for its inverse, the domain of the inverse is x is greater than or equal to 0 as well, and the range of the inverse is y is greater than or equal to 0. Again, we see the relationship where the domain of f is the same as the range of the inverse, and the range of f is the same as the domain of the inverse. For our second example, we're going to consider the function f of x is equal to 4x minus x squared, which is an upside down parabola. For this function, when x is less than or equal to 2, our function f of x is monotonically increasing, and when x is greater than or equal to 2, f of x is monotonically decreasing. If we want to have an inverse function, we can either restrict the domain to x is less than or equal to 2, in which case we're going to be getting this half of the function, and this will be our corresponding inverse function. If we restrict the domain to x is greater than or equal to 2, we're going to be looking at this half of f of x, and this will be our corresponding inverse function. So we can see that by restricting the domain of our original many-to-one function, we again can create inverse functions which are also symmetrical about the line y is equal to x. Let's also look at the relationship between the domain and range of f of x and its inverse. From our second example, when we restrict the domain of f of x to x is less than or equal to 2, the domain of f is given by x is less than or equal to 2, and the range of f is equal to y being less than or equal to 4. For its inverse, the domain of the inverse is x is less than or equal to 4, and the range of the inverse is y is less than or equal to 2. What we see here again is that the domain of f becomes the range of the inverse, and the range of f becomes the domain of the inverse. And what about when we restrict the domain to x is greater than or equal to 2? This time, the domain of our original function f is x is greater than or equal to 2, and the range is still y is less than or equal to 4. For the inverse, the domain of the inverse is now x is less than or equal to 4, with the range of the inverse being y is greater than or equal to 2. We once again see that the domain of f becomes the range of the inverse, and the range of f becomes the domain of the inverse. In summary, what we learned in this video is that when we take the inverse of a many-to-one function, we don't straight away get an inverse function. We get what is called an inverse relation. If we want to get an inverse function from a many-to-one function, we need to restrict the domain of the many-to-one function in such a way where the new function with the restricted domain is either monotonically increasing or monotonically decreasing. The graphs of f of x and its inverse f to the negative 1 of x will still be symmetrical about the line y is equal to x, and the domains and ranges of f of x and its inverse are also interchanged. This means that the domain of f is equal to the range of its inverse, and the range of f is equal to the domain of the inverse. Thanks everyone for watching the video. I hope you guys enjoyed that. For more videos on this topic or other topics, please have a look at our channel. We release videos weekly across various maths topics, so if you haven't already, don't forget to subscribe. We would love to see you all in the next one. Bye for now.